Most teams that take secret security seriously have a clear rule. Secrets do not go in the repository. They use a secrets manager. They inject credentials at runtime. They rotate regularly. The policy is sound, and then a developer adds a build step that prints environment variables for debugging, and every secret injected into that pipeline is now in the build log, retained for 90 days, readable by every engineer with access to the CI platform. This is not a story about the rule being broken. The rule was followed. Secrets were not committed to the repository. They were handled exactly as the policy required. The build step that exposed them was added for a completely legitimate reason by someone who was not thinking about secrets at all, in a part of the system that the secret security policy had never considered. CI/CD pipelines are secret-dense environments. They have to be. A pipeline that builds, tests, and deploys software needs credentials to pull from private registries, access to signing keys to produce artifacts, tokens to push to deployment targets, API keys to notify external services, database credentials to run migration tests, and cloud provider credentials to provision infrastructure. All of those secrets need to be present for the pipeline to do its job, and the pipeline is, by design, a highly automated, highly instrumented system, one where every step is logged, every output is captured, and every artifact is stored. That combination, secret dense and fully instrumented, is what makes pipelines such a consistent exposure surface. The most direct exposure path is build log leakage. Pipeline logs are verbose by design. Engineers need to see exactly what happened at each step to diagnose failures. That verbosity means that any step which echoes its inputs, prints its environment, or produces output from a command that received a secret as an argument will write that secret into the log. Shell commands that expand variables in error messages. Test frameworks that print environment context on failure. Dependency installation tools that log the full command, including authentication headers. Docker build commands that print ARG values during layer construction. Docker image layers deserve particular attention because the exposure is less visible than a log entry. When a secret is passed as a build argument to a Docker file, a common pattern for providing credentials during the build process, and that ARG is used in a run instruction. The value is baked into the image layer history. Docker image layers are not just the final full-list state. They are a record of every instruction executed during the build, including the values of arguments at the time they were used. Anyone who pulls the image and runs Docker history on it can read every ARG value from every layer. Anyone with access to the registry where the image is stored has access to every secret that was passed as a build argument. This is a category of exposure that persists silently for a long time. The image is built, the build succeeds, the application deploys correctly, and somewhere in the layer history of an image that is now running in production is a credential that was supposed to be ephemeral. Pipeline configuration files create a different exposure surface. Build pipelines are typically defined in YAML or similar formats committed to the repository alongside the code. Those configuration files define which secrets are injected, how they are named, what permissions the pipeline runs with, and what external systems it connects to. An attacker who reads the pipeline configuration does not necessarily obtain any secrets directly, if the secrets are properly stored in the CI platform. But the configuration reveals the complete map of what secrets the pipeline uses, which systems they authenticate to, and what those systems can be used to reach. That map is the reconnaissance that makes a targeted attack on the pipeline much more efficient. Third-party pipeline actions compound the risk in a way that is still not widely understood. Modern CI platforms allow pipelines to use actions or plugins contributed by the community, pre-built steps that perform common tasks like deploying to cloud providers, sending notifications, or running security scans. Those third-party actions run inside the pipeline with access to the pipeline environment, which includes every secret injected into it. An action that reads environment variables, which all of them can do, has read access to every secret the pipeline holds, regardless of which step was supposed to use which secret. The trust model here is worth making explicit. When a pipeline injects a secret into the environment and runs a third-party action, it is extending implicit trust to that action. Trust that the action will not read secrets it was not intended to use, will not exfiltrate them, and will not behave differently when it detects it is running with elevated access. That trust is not auditable at runtime. The organization has no visibility into what the action reads from the environment during execution. The only available control is scoping secrets to specific steps, rather than injecting them into the full pipeline environment, which most pipeline implementations support but most teams do not configure. The underlying problem across all of these patterns is that pipelines were designed to automate software delivery, and the security model for secrets inside them was added incrementally as the risks became apparent. The result is an architecture where secrets are present everywhere they are needed, which is correct operationally, and where the boundary between where secrets are needed and where they are merely accessible was never clearly drawn. A pipeline that injects all required secrets at the start and runs every subsequent step with access to all of them has made every step equally trusted with every secret. That is rarely what was intended and almost never what is needed. Scoping each secret to the specific step that requires it, running third-party actions in isolated environments, and treating pipeline logs as potentially sensitive outputs rather than purely operational data are not difficult changes. They are changes that require someone to have modeled the pipeline as a secrets exposure surface in the first place. Most pipelines were never modeled that way. They were modeled as automation. And automation that handles secrets without a security model is a machine that occasionally, silently, puts secrets somewhere they were never supposed to go.